I don't know. I haven't gotten far enough yet.
80, isn't it?
80, yeah.
How are we gonna do 80 if they take 50?
I don't know. I have some work to figure out, don't I? Well, the material, a lot of the material is very easy to understand. It's just there's a lot of new material to get through that you guys haven't dealt with before. No, I haven't looked yet.
Back to the good call.
Yeah, we can't take tests because we want enough grades to take tests.
That's why we have wraparound periods.
So,
That's funny. We need 80 lessons though.
Yeah, I know. So we have like, I don't know, like 6 wraparound periods or something like that. So we'll be fine. All right, 1.2, we're going to be talking about basically data and sampling. We're also going to talk about a little bit about variation in each one of those. All right, there are different types of data, as you can see up there. Qualitative is the result of categorizing or describing attributes of a population. So say, I mean, most of the time data, we're talking about numbers, but not always do we have numbers. Say we split you guys into boys and girls. Those are not numbers. Whenever you don't have a number and you're categorizing by something like that, then it's qualitative data. All right. When it is a number, then it's called quantitative data. And we can break those quantitative data points down into 2 categories. We can split them up by what's called discrete data, which is whole numbers. All right. Or we can do quantitative continuous data, which can be any numbers. It can be fractions, decimals, irrational numbers, anything like that. All right. So whole numbers is discrete. Fractions, decimals are continuous. All right. If you don't have any numbers, if you're talking juniors and seniors, how many juniors are in the class? How many seniors are in the class? You're splitting them up based on putting them into a group. That's not a number. That is qualitative data. It's 20 and 2, kind of. All right. So any questions on that? Okay. The big thing for this is just to figure out the differences between them. It's not hard to realize the differences, but it's more a memorization type thing. All right. So here's a couple examples. Probably don't need to write them down. Take a look. The data are the number of the machines in a gym. You sample 5 different gyms. One gym has 12 machines, one has 15, one has 10, one has 22, and the last one has 20. What type of data is this? First of all, is it qualitative or quantitative? It's quantitative because there's numbers there, right? So this would be quantitative. All right. Then from quantitative, we can split it up into discrete or continuous. What type of numbers do we have? Yep, it's discrete because it's whole numbers. Okay. So, all right, down below, the data are the weights of the backpacks with books in them. You sample 5 students, the weight of their backpacks are 6.2, 7, 6.8, 9.1, and 4.3. What type of data is that? Quantitative because it's numbers. And then is it discrete or continuous? It's continuous because they're decimals. Okay, that's the only difference between them. Okay. Next slide. The data are the colors of the backpacks. Again, you sample the same 5 students. One has red, 2 have black, 1 has green, and 1 has gray. What type of data is that? Qualitative. That is qualitative because they're separated by the colors. Okay. All right. Let's see. Determine the correct data type, quantitative or qualitative, for the number of cars in a parking lot. So we go out to the parking lot. Why is it quantitative? Because you can count them. Yep, you're going to get a number. All right. Is it continuous or discrete? Are you sure? Depends on how old the car is, right? All right, no, that should be discrete. All right, any questions there? All right, see, even though it's 15 slides, it's not going to be that bad. All right, here, we have got some charts here. We've got some charts from 2 separate colleges. All right, now, why are you saying that, Eli? Well, is it discrete or continuous? Well, okay, so this one, we got to figure out what they're talking about, right? Okay, if we look at that, they are talking about full-time students and part-time students. All right, can you have half of a student? It kind of tells you what type of data we have then, right? So this would be discrete. So this one you have to look at a little bit more closely, all right, to figure out exactly what's going on here. All right, because the data points are just going to be the number of students. What they did here in the second column for both of them, they just changed them to % of full-time students out of the total, okay, for both of these. Okay, now, one thing to realize real life-wise, how we use stats is sometimes we use stats to get numbers across, okay? For a lot of people, maybe some of you included, this just looks like a mess of numbers, okay? I don't want to think that much, okay? And that goes for a lot of people. I don't want to think, all right? So we put it into a chart instead, all right? If we look at this chart, what they did was they put the goldish color here as part-time students and the purple color as full-time students, all right? If you look at that, what might you be led to believe here? There's definitely more part-time than full-time for both colleges. And between the 2 colleges, we have more part-time students than part-time students here, right? Okay, and this is where you have to be careful, because if we go back and look at the data, is that actually the case? Here's our part-time number, or I'm sorry, that's full-time. Here's our part-time number here. Here's our part-time number here. All right, so if you are making a chart for Foothills to compare it to the other college, maybe you do make a chart like this to show, yeah, we have the same number of kids, which they actually don't. But it's going to look that way, doesn't it? Okay. Also, take a look at the little chart here that I put here. All right. If you look at the charts, this is talking about student status. It's hard to read. Okay. I made it this way on purpose, and I'm going to show you why in a second. If you just quickly glance at that, do they kind of look, those bars kind of look very similar, especially the light blue ones? All right. Now, I jammed it together on purpose like that so that they do kind of look the same. You spread it out, you can definitely tell a difference there, can't you? All right. So we talked about this the first day, that with statistics, you really got to figure out what's going on before you can trust the statistics in front of you. Okay. People will manipulate, and I didn't really manipulate much. All the information's there. I just took a person's laziness against them and said, all right, you look at the light blues, they're about the same until you really expand it out so you can actually read it. And then you can start to tell a big difference there. Okay, so when you do this in the real world, you've got to be aware of that is being used on us. Sometimes it's being used against us. so that they can get the point across that they want to get across to us. All right. Any questions so far? Okay. All right. Here's another one. All right. Those same colleges, actually, it's just the one, the De Anza College. Okay. Put together these stats for us. Okay. Full-time students, out of all their students, 40% of their students are full-time. Okay. Students who intend to transfer to a four-year college after they're done there, 48%. Students under 25% or under age 25, 61%. All right. What number should not be up there at all? Yeah, this total doesn't make any sense at all, does it? Okay. You can't have over 100% of your students involved in any kind of survey. So if you're going to do something like this, make sure that you do not, if you don't put the total there, there's nothing wrong with those three statistics there at all. All right. You just got to be aware. Okay. Now, if I were to look at this chart and I go and I look at stuff like this, that makes me question the validity of the whole thing that they just did there. Okay, because I know that you can't have a total of over 100%, okay, for something like this. So I would start to think, is any of it accurate? Okay, now there are ways to put this into a chart though. Say you don't want to throw the numbers out there. Can you put something like this into a pie chart? Why not? Yeah, to have a pie chart, you have to have 100%. Okay, so instead, if you did a bar graph, that'd be totally fine. Okay, that shows the information very well. Okay, now how you label each one of these down below, the order that you put them in, totally up to you. Could you put, do you have to put this last column here? You don't have to. I would assume that most people would think that if you put, 100% would be all students there. All right, so something to consider. All right, something to think about as we're going through this. Okay, here's another one. Same school. All right, we're talking about ethnicity here. Okay, now most people, if you put all of this on the same page, are you gonna look at the numbers first, or are you gonna look at the pie chart first? Okay, all right. Okay. Right, the top plays into effect a lot, okay, for a lot of people, especially, and if you look at the numbers, they're a little bit bigger than the pie charts down below, all right? Something to think about, okay? Is there an issue with the numbers up top, though? Do you see any issue that might be there? Right. So it makes you think there are, if you look at this, there's 2,000 students here that are not accounted for. Why is that? And where do they fall? It's possible. Okay. And there's lots of different reasons for that. Okay. And so for something like this, could we put, instead of total, could we put like the word other in here? Okay. All right. And then you're going to put the 2,000 and however many that are left there. Okay. And once again, you don't really need the total here. All right. Once you do that, then you could definitely throw it into a pie chart. Okay. And you could technically do either one of these. Which one's a little bit easier to read, especially if you're just trying to compare the groups there? Why? Caitlin says the one on the right. Yeah, they're kind of in order from the biggest to the smallest. Okay, if you want to know what the biggest group is, well, we don't have to analyze the whole pie here. Okay, we can just look and say, all right, that one's obviously bigger than all the rest of them. I mean, you can do that just as well here, but this information is much better organized. All right. So, questions there at all? See, you guys were worried about 15 pages. We're flying, right? All right, and then we grind to a stop here. You need this stuff. What? All right, sampling. There are 5 different types of samples that you can take here. I'll give you a little time to write this stuff down. Now, you may remember some of these names from Algebra 2. We talked about this a little bit in Algebra 2, about the different types of sampling. We did not talk about the convenience sampling. That one was new to me, and it makes a lot of sense why it's thrown in there also. All right, the first one, as it says up there, is simple random sampling. All right, so as it says, every person in a group has an equal chance of being chosen. All right, so let's say that as you guys are coming into the room, you drop your name into a hat, okay? As long as all the sheets of paper are equal size, you're not allowed to fold them, or if you are allowed to fold them, they're folded the exact same way. Then everybody should have the exact same chance of being chosen. That would be simple random sampling. All right, and that is the most popular way of doing sampling. All right, it's also the easiest, like laziest way of doing it too. All right, your stratified sample, as it says, you divide your population into groups, and then you do the exact same thing that we talked about. So instead of all of you guys putting your names into the same hat, say I want one boy and one girl to win. Well, I'm going to split you into those groups, and then we do the exact same thing. All right, so that would be a stratified sample when we split them into groups and then do an SRS. A cluster sample is you divide your population into clusters or groups and then randomly choose that group. So an example for that would be, you guys are already in groups. You guys put yourselves into groups the first day of class, okay? You put yourself into rows, okay? I could look at that and I could say, all right, you're in your group. I'm gonna randomly choose a group. So everybody in row 2 gets extra credit for today.
Yeah.
All right, you're not in row 2.
Yeah, yeah. Row 2.
Okay, so are rows that way or are they this way, right? All depends on what I decide, right? No? Yes, you are correct. Yes, even going with the math stuff I've taught you. Yes, rows go side to side, columns go up and down. All right, so everybody in C2 apparently gets extra credit. I don't know. Okay, that works. All right, so that is a cluster sample. When you divide them into groups and then randomly choose the entire group. Systematic sample, every 8th person coming into class gets extra credit. Okay, now you'd have to pay attention the whole time to who comes in. All right, so it takes a little bit more work on your end, but it should be a fairly consistent sample throughout the entire process. Okay, the last one's very interesting. It makes a lot of sense to me. Like I said, I had just never heard of it before. You use the results, they're readily available. So say that I want to sample the entire school, but I'm going to take the lazy way out. And I'm going to say, I've got a class at 20 right in front of me right now. You 20 are the ones who get to choose here. Okay, so I'm going to be lazy. I'm just going to take the results from you 20. All right, and that would be convenience. All right, any questions with that? All right, so this one might want to read more than anything else. Sampling data should be done very carefully because it can have very devastating results. Okay, our election process is a very good example of this. Okay, it kind of drives me nuts on election night that Hawaii and Alaska don't close their elections for a long time after we start getting results from the East Coast. Can that influence big time how people are going to vote? Yeah, it can. Okay, should it happen? I don't know. I don't make those rules, but it can have a very devastating results on the entire thing. Okay, now they're small states, and that's probably why they leave it the way it is. Okay, because they only have 3 electoral votes for each state. So, you know, they're not going to skew it too much. But we do have California on the West Coast, who, when they start to hear the results from the East Coast, can that skew a really, really big state then? It could. I don't think it ever has drastically, but it could. Okay, another way, as I set up there, an example would be surveys mailed to participants can be very biased. Okay, the reason why I'd be biased is, say you only mailed it to a certain ethnic group. Say you only mailed it to a certain financial group. Okay, that can have a huge result based on a lot of people in those groups may think very similarly. Instead, better results can be had by individually selecting the respondents. Okay, true random sampling to get the best results is always done by replacing. Okay, so for example, we had that hat. You guys all put your name into the hat. I draw 1 to get true random sampling out of the deal. After I pick one, I should put it back. Now that does mean that that same person can win again, right? Okay, but you will get the most consistent results by putting the names back. All right, sampling bias is also created when a sample is collected from a population and some members of the population are not as likely to be chosen as others. Okay, so you put everybody's name into a hat, okay, but instead of everybody getting the same results, okay, you guys know, if you guys have done this enough, okay, if I give you a slip of paper and you want your name to be chosen out of that, what should you do to that piece of paper? How are you going to make it bigger? Everybody got the same sheet of paper. Fold it bigger. Yeah. Okay. Okay. Fold it with lots of different angles in it. Okay. And then your surface area is still the same, but the area that your sheet of paper is using is much bigger. Okay. So yeah, you can influence that. Okay. That would be a bias that could be thrown in there. Okay. Say that, let's see, juniors are in charge of prom, right? Say that a certain group of juniors wants to get their stuff put across. Okay. Maybe they put a meeting at a time where only people that think the same way they do can make it. Yeah. All right. So there's all sorts of different biases in these things. All right. Common bias issues. All right. Problems with the samples. A sample that is not representative of the population is biased. So, for example, all right, say I want to poll the entire school, okay, about what classes freshmen should take. But I only poll you guys. Well, am I going to get the best results? I mean, you guys have lived through freshman year, so you know what's available. Okay, so you do have prior experience that, say, younger kids don't have. All right, but you could also go, I don't really care. You know, so there can be biases with that. Okay, another one, self-selected samples. Responses only by people who choose to respond are often unreliable, such as call-in surveys. Say we use that exact same thing. All right, Matt decides this is stupid, I don't want to do it. All right, Ethan follows suit. All right, okay. If I start to choose people, I go, all right, Elliot wants this class that I want to have in the school added. I want to choose Elliot to be on there. And Elena thinks the same way, so I'm going to choose her, and so on. I keep choosing people that I want to be in the sample. There's a whole bunch of bias thrown in there. Okay? Sample size issues. If you only choose a sample size, we have like almost 400 kids in the school. If you only choose 10 kids as part of your sample size, it's probably not going to be a good representation of the entire school. So you got to make sure. Now, you might not have enough time to get to all the kids in the school, but you need to have a large enough sample size to be able to make it reliable. Undue influence, collecting data or asking questions in a way that influences the response. All right. So a way that you ask a question can definitely influence a result. Do you agree with me that this should happen? Well, of course, it depends on what it is, but am I already telling you, I think this way, I want you to think the same way as me? All right? That can have influence on it, which can cause bias issues there. Okay? Some more bias issues is causality. Okay? A relationship between two variables does not mean that one causes the other to occur. Okay.
Thank you.
Please stop making that.
I'm on the last
We're
one.
trying to.
I'm not done. Sorry.
I really hope they're not like match the definition.
No, more often than not, if I ask a question like this, it's kind of like the examples we went over a little bit ago.
Oh.
And we'll go over some more examples in just a few minutes where here's the situation, what type is it?
All right.
Okay, or here's the situation, is there bias in there? And what kind of bias is it? So
That's worse than that.
sometimes,
Tell us the options.
sometimes, like I might give you a list of like 7 different, like we just went through the, yeah, I could do something like that. Which one would it fall under?
Not be like, is it this one or this one? Just like
Yeah.
a list.
Yep.